Okay, so our 5.1 notes. First thing we need to be a little bit refreshed on is we're talking about angles here. Okay, in fact, I should give us a title. We have angle measures. We're going to talk about coterminal angles. We're going to talk about reference angles. All of those are things that were addressed in the spring, so hopefully it's review if you were participating in the spring. If you weren't participating in the spring, then it's not going to be review for you. Okay? And you're going to be held accountable for it now. So what I have here is an XY axis, right? And some things we know about the XY axis. We know that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. We know that, right? That's a piece of cake. Yeah? In addition to that, we learned in the spring about these things called angles in standard position. Let me try and use a different color here. And we always have an initial side that is right there. Yeah? And then we have another side, usually known as a terminal side, somewhere else. And if we have a positive angle, we start off going in a counterclockwise direction. So a positive angle goes counterclockwise. Okay. Have I lost anybody yet? Still good? Okay. What happens if my initial side always is in the same place, but what happens if my angle goes down here and I'm talking about this part right there? What do I have there?
It's negative.
I have a negative angle. So negative angles go clockwise. Okay? So far so good? Then we also have these things where sometimes we have our initial side there and perhaps our terminal side lines up on a axis as well. What do we call that? Anybody know? Starts with a Q. A quadrantal angle. It's called quadrantal when that terminal side, this guy right here, is not in any quadrant, it's on an axis. Okay? Now, how many degrees is this angle right here? This one that's pictured, if it's going up like that,
Is it 90?
that would be 90 degrees. Yes, it would be. What would happen if it came all the way over here? What's this measurement?
180.
180 degrees, and all the way down here is 270 degrees, and if it makes it all the way around, it is 360. Okay, so hopefully that part there is mainly refresher for you, yeah? Awesome. Now we're going to talk about something that the Babylonians gave us way back in the day, before any of us were even thoughts. We can talk about angle measure in something called DMS. It is called degrees, minutes, seconds. And it has to do with the fact that the Babylonians did not use a base of 10 for their number system. They used a base of 60. And a base of 60 leads us right into the way we think about minutes and seconds. Okay? So here's our first example with degrees, minutes, seconds. And this is the kind of problem you'll see on your homework. Okay? So you would get a problem that says something like this. Change 139.125 degrees into degrees, minutes, seconds. So that's what the problem would say. Okay, and let me show you how to do it. Now, the 139 part, that's going to be our degrees part. So I'm going to say this is 139 degrees. And the decimal part is the part that I have to deal with minutes and seconds on. Okay, now I said that they had a base of 60, right? So here's what I'm going to do. I'm going to say 0.125, which is the decimal portion there. And I have to multiply it by 60 because the Babylonians gave us that base of 60. What do I get when I multiply 0.125 by 60? Anybody? Gotta grab my 7.5. So I have 139 degrees plus 7.5 minutes. And we do one little apostrophe there to refer to minutes. Now I still have a decimal, don't I? So this decimal here is going to give us our seconds. So watch what I have. I have 139 degrees plus 7 minutes plus 0.5. And again, I'm going to multiply it by 60. And we use two little apostrophes, almost looks like a quotation mark, to mean seconds. So I'm keeping the whole number. I'm just taking that decimal part and multiplying it by 60 each time. So let's see what I got. 139 degrees plus 7 minutes plus, what's 0.5 times 60? Isn't it 30? Yeah? And that's the end. So the way I write my answer is just 139 degrees, 7 minutes, 30 seconds. So? I know it's kind of funky. Okay? You try this one. I'm going to give you an angle. Change negative 16.75 degrees to DMS. So see what you can do with that guy. Doesn't matter that the first part is negative, it just means that your answer is negative. So far, is this what you got? The 0.75 times 60. So let's see, that's negative 16 degrees plus, what is 0.75 times 60? By the way, that's minutes. 0.75 times 60, anyone got that?
45.
And guess what? I have no decimal left, do I? So this just changed into negative 16 degrees, 45 minutes, and there are no seconds for that one. There would only be seconds if there was still a decimal that you had to multiply by 60. Sort of easy. So. Okay. Let's go backwards now. What if I gave you the degrees, minutes, seconds, and I wanted just the plain old degrees? Okay, so I'm going to call this example 3. Change 35 degrees, 12 minutes, 7 seconds into, they call it decimal degrees. And they say rounded to the nearest thousandth. meaning I want 3 digits past the decimal. Now, if we multiplied by 60 when we were going to the degrees, minutes, seconds, what should we do you think when we're going the other way? What's the opposite of multiplication? Division, right? Now, it's a little tricky, but I'm going to take my 35 degrees, and I'm going to take 12 minutes, and I'm going to multiply again, but I'm going to multiply by 1/60th, because that means the same as dividing by 60, right? But think about this for a minute. When I was going this way, I multiplied everything by 60, and then I multiplied by 60 again. So that second part of the decimal was actually times 60 times 60, wasn't it? It wasn't just times 60 once, it was times 60 twice. So my seconds, I have to divide by 60 times 60. What is 60 times 60? I'm sorry, 60 squared. I actually have to multiply it by 1 over 3600, which is 60 squared. Which is 60 times 60. This is going to get me my answer. So let's see, 35 degrees plus, what is 12 times 1/60th? 0.2. And then 7 times 1 over 3600, I get 0.0019, and just give yourself about 4 digits there. What do I get when I add all those things up? 35 plus 0.2 plus 0.0019. I get 35.2019. Keep in mind we're talking about degrees. And then just check your rounding. You're rounding to the nearest thousandth, which means 3 digits past the decimal. So what's going to happen to that 1? It becomes a 2. So I have 35.202 degrees. Okay, so the key with these guys is remembering, my highlighters go, is remembering that you multiply the minutes by 1/60th, but you multiply the seconds by 1 over 60 squared, which is 1 over 3600. Any questions there? So? Okay. I do want to show you a negative example on these ones because the negative ones are a little different. So change negative 405 degrees, 16 minutes, 18 seconds into decimal degrees. And again, that's going to be rounded to the nearest thousandth again. Now with a negative angle, this is a different type of problem, sort of. With a negative angle, you do the exact same process. It's just instead of plus signs here, they need to be minus signs. Okay, so negative 405 degrees, I would do minus 16 times 1/60th, and then minus 18 times 1 over 3600. Because for negative angles, we need every part of it to be negative. So let's see, that's negative 405, and then let's see, 16 times 1/60th is plus minus 0.267-ish. We'll call it 667 just to stay with our things. And then 18 times 1 over 3600 is minus 0.05. And you could do this all on your calculator at the same time. If you wanted to, you could just do 405 minus 16 times 1/60th minus 18 times 1/3600th. 404 point, sorry, I didn't do that negative, did I? Negative 405 minus 16 times 1/60th minus 18 times 1/3600th. There we go, negative 405. I was like, wait a minute, we ended up with less degrees. So negative 405 degrees. And then I have my decimal there. Sorry, I should have written that. Negative 405.2716 would be 272. So that's my decimal degrees. So you don't have to write out this step. You can just go straight to your calculator here and get to your answer there. Okay? Hopefully that kind of makes sense. Again, I'm recording this so you can go back and check it if you need to. Also on your homework assignment, I have provided the odd answer so you can check yourself periodically on the way through. Okay? All right, next type of problem. Moving away from degrees, minutes, seconds. I want to know, give the angle represented by 9.5 rotations clockwise. I'm going to call this part A because there's also a part B. So 9.5 rotations clockwise. So my question is clockwise positive or negative? Clockwise is negative, right? So I need to think about this. If I were to draw the picture, we're going in a negative direction 9.5 times, right? I don't want to draw that. That's going to be way too much. So here's what I can do. I can do 9.5 times 360 degrees, right? But if I'm going in a negative direction, I want to multiply it by negative 360. What is 9.5 times negative 360? Negative 3,420 degrees. So 9.5 rotations clockwise is equivalent to 3,420 degrees. So? I'm not seeing any questions, so I'm assuming we're getting it. What if I said, what is the degree, or what is the angle represented by 6.75 rotations counterclockwise? Well, I would take the 6.75, and this time if we're going counterclockwise, we're going positive. So I'm not going to multiply it by negative 360, I'm going to multiply it by positive 360. What do I get when I multiply 6.75 by positive 360? 2,430 degrees. We doing okay there? Yeah? No? Yeah? Okay. Let's see. Just a couple more things on this lesson that I want to make sure you know. It's going to talk about coterminal angles. Somebody unmute themselves and tell me what coterminal angles are. Anybody? Any takers? Nobody? Coterminal angles are two angles in the same standard position. In other words, their terminal side is in the same location. All right? So if I look at an angle that, let's say the terminal side is right here, the coterminal angle to that is going to be that one. Just adding another revolution. Or the coterminal angle could be, let me get another color, see if I can do this. The coterminal angle could be that one, and that pen works horribly, doesn't it? But it's any combination of the swirlies without moving the terminal angle or the terminal side. Okay, so how do we find coterminal angles? You either add or subtract 360 degrees. Okay, so identify all angles coterminal with 86 degrees. Then find one positive and one negative coterminal angle. So when it says identify all coterminal angles, that means it's asking me for a formula. Like, how could I find all of the angles that would have a coterminal side at the exact same location as 86 degrees? Well, it's pretty simple, because when you're finding a coterminal angle, you're adding or subtracting 360. So anytime I take 86 degrees and I add or subtract some multiple of 360, I could add or subtract 2 360s or 3 360s or 4 360s. They're all going to be coterminal. So when it asks for all angles coterminal, you just slap on this plus 360k, and that's going to give you your formula to find any angle that's coterminal. So? Okay, now I need to find one positive, one negative. So if I do 86 degrees plus, let's do one rotation, making K1, using that. That would be 86 plus 360 times 1 is just 360. There is 446 degrees. That is a positive coterminal angle to 86 degrees. If I want a negative coterminal degree or coterminal angle, do -1 for K, because that would mean I have a negative direction instead of a positive direction, because that turns into 86 minus 360, doesn't it? -274. You can't see that because it's glared. -274 degrees would be my negative. I have a positive angle and I have a negative angle, and I know they're coterminal because I used that form to help me. So? Okay.
Miss Franken?
Yes.
What does the K represent? Because I'm confused about the K.
Okay. The K represents the number of rotations. So, in other words, when I started here with this angle right here, if I want to add one more rotation, that's giving me this red swirly here. I could add another rotation, making a K value of 2. And then I could even add another one, making a K value of 3. It's just how many times you're circling around. But every time, as long as it's 360, as long as it's a multiple of 360, you're getting something that's coterminal.
Okay, thank you.
Okay? So I could find another positive coterminal angle if I wanted to. I could make that 5 if I wanted to. That does give me another coterminal angle. It's just usually easiest to stick with the ones that are closest to it as opposed to making bigger ones and bigger numbers. Okay?
Thank you.
All right, last thing for this lesson is reference angles. Okay? Reference angles. You ready for these? Good answer. Hang on, let me make sure I got my examples right. Okay. A reference angle is a positive, and it's key that it's positive, acute angle formed excuse me, by the terminal side of the given angle and the x-axis. Always the x-axis, never the y-axis. So, I'm going to draw some quick examples for you. Okay, if I have, I'm actually going to draw 4 examples for you. Whoop, sorry. Okay, so in the first one, if my angle is in the first quadrant, my reference angle is right here. Okay, if my terminal side is in the second quadrant, my reference angle is right here. So? If my terminal side is in the third quadrant, my reference angle is right here because, again, it has to go to the x-axis, never to the y-axis. And finally, if my terminal side is in the fourth quadrant, my reference angle is right here. So here's my reference angle. I'm just going to abbreviate it RA if that's okay. Okay. So, last example here. Find the measure of the reference angle of 312 degrees. So let's think about this for a minute. 312 degrees. First off, what quadrant is the terminal side in of a 312 degree angle?
Quadrant 4.
It is in quadrant 4 because if we remember, we had 90 degrees, 180, 270, not 18, 270. So 312 is something down here, right? 312 is something down there. So where is my reference angle going to be? Well, for a fourth quadrant one, my reference angle is actually going to be that. And there's a couple different ways I could find that. I could understand that this is 270, which means that this right here is what, 42? In order to get to 312. And then I could figure out this by subtracting from 90. Or, in this particular case, I think it's going to be easiest to take the full rotation and subtract the angle. Because will that give me a positive acute angle? And it will leave me with that, right? So what is 360 minus 312? 48 degrees. That is my reference angle for a 312 degree angle. Okay. Now, it doesn't matter how many loop-de-loops there are in here. So in other words, every angle that is coterminal with 312 degrees will also have a reference angle of 48 degrees, because they're all going to have the terminal side fixed in that same spot. Okay, now I know that's a little bit of review for you. I'm going to go ahead and upload this video. Okay,